Okay, we are live. I think we should just give folks a few moments to join and trickle in. Welcome.
Maybe while we wait, just some fun trivia for you guys. I was supposed to be back in SF and hang out with Willem to do this webinar, but the gods had different plans. I got stuck here in New York with the blizzard. Things are a little bit nicer today, though. So hopefully I'll be on a flight back to SF tomorrow.
Are you stuck in your hotel or?
I wouldn't say stuck. It's actually quite nice outside. But yeah, I am figuratively stuck till tomorrow.
Okay, so
Uh,
it's snowing a little bit. Um,
it
okay, I
is, it
think we
is.
can we can probably kick things off. So, welcome everybody. My name is Willem, and I'm joined here today with my co-founder Shahram. Today we'll be talking about what the theme is beyond investigation agents. So, building operational memory that compounds, and the TLDR is we believe that memory is a key component of building a system that can operate in the production environment where investigative agents are commoditizing. So my background is in machine learning operations and data systems. So led and built ML platform teams and created the open source project called Feast. I'll let Sharon do a quick intro as well.
Willem's a celebrity in the group, the creator of Feast. But yeah, like I have a similar background. I've had one foot in the platform engineering world, one foot in the ML world. So my last role was running the ML platform at Gojek. It's like the Uber in Southeast Asia, and that's really what inspired me, and I guess for a lot, but Willem as well to start Cleric, because we kind of saw just the future of how AI can help make some of this production work a little less toily.
Okay, so let's jump into it. So today's agenda will be a few topics. How AI is changing software production, and this is not just limited to the production environment or AI SREs, but just like as engineers, how does AI affect us today? But then specifically in the production environment, where do we see the problems occurring, the bottleneck, and what our thesis is on the missing piece, and the architecture that we think is necessary to succeed with AI, I guess through the whole SDLC. And then we'll show you a demo of the way we've approached the problem with our product and why memory matters so much. And we can dive into Q&A. So we want to keep this lightweight and keep this very interactive and get into the Q&A as quickly as possible. So I'll hand it over to Sharam to just take you through the first section.
Cool. Thanks, Willem. I think it's always helpful to just zoom out a little bit and look at the whole SDLC, right? We've had coding agents just taking us by storm, I guess. Like definitely towards the end of last year, it seems like everybody has tried Cloud Code and Codex and Gemini CLI. But for us, to me, like the constraint was never really code generation speed, although like it's magical, like just seeing it work. It's really always been beyond like the CI/CD and production. And the way I like to think about this is just think about like feedback loops. Like how expensive is a feedback loop to know if something went wrong? How can you fix it? So it's really fast, of course, right? Like in a loop, you can write a test, the coding agent can see if things are going well. But once you push to CI, now you've got to actually figure out like if something failed, it's not obvious what went wrong, and it's usually like a lot worse and a lot more expensive in production. So that's where most of this webinar is going to be focused on, like, and that's what our focus is on with Cleric. How do you actually get this feedback loop to be tighter in CI/CD and prod? Now, even before, as I said, like the code generation speed was not really the problem, but at least all of us were writing that code, and you kind of feel like you understood what was going into prod, right? So I don't know for all those of you listening how much you've gonna have a smiley face with the previous generation, but at least like generally you knew what was going on. I can say at least like even on our end, we're using agents heavily, and prod looks a lot like on the right side where it's just a lot more AI code. So I think you've got much more code and a lot less context of what's going on. Now, I feel like we can spend a lot of time figuring out like, okay, how do you actually make this more resilient and safe? But the issue is that this is actually just going to accelerate. I think the likelihood of like the amount of human code as a percentage of total code is just going to keep going lower and lower. And so I think a much more interesting discussion to have now is like, okay, what does that mean, and how do we actually prepare for this world, right?
And to be fair, that is a good thing, right? You do want more code to be shipped by AI into production.
Hmm. Hmm. Exactly. So we spoke to a bunch of people, like especially we have very frequent conversations with our customers, and we're always trying to figure out like how are people thinking about this. Um, a big part of at least from production is that you have a symptom where people are say we're drowning in pages or alerts, but really the problem is not really the volume, it's the complexity. So even if you have 100 pages and 99 of them are false alarms, it's annoying, but that's not really a problem. But then you do get these instances where, we had a customer 2 weeks ago where they said they kept getting woken up because there was this problem that they just couldn't figure out. And that's where, like, when gets more complex and you don't have the context to figure out how to root cause it, that becomes a challenge. Then, the even at the smaller level, like even for our company, there's only a few engineers, but you end up getting these hotspots of knowledge that you see, right? So it becomes very, especially as you scale, it becomes harder and harder for each individual engineer to hold the full context of production and what's going on in their head. And that's why we have meetings, Zoom calls, services, and Conway's Law and all that stuff. So I think as more and more code comes through, then you're going to have even more of a challenge, like keeping this context in. And this is, I'd say, our biggest focus because if you think about like a new engineer walking in, the thing that's missing is not really hard skills. You're probably testing for that when you're doing an interview. It's really about the tribal knowledge that as engineers you've gained, right? So the engineer who's been around for 5 years, 6 years, 7 years, they just know they have all these past failure modes and how things, have worked, how things have broken in the past. That's all in their head, and that I'd say is what gives them their edge on how to actually look after production, make sure things are stable. So this is not a unique problem. I think most of us in the industry have seen this. Like even pre-AI, we've been trying to solve it. But now that AI has really started coming in, I think it's more curious, like how are we trying to solve it? So the first one which we've seen is like people are trying to build it themselves with LLMs. I think it's a good start. Like we'd always love to talk to folks who are actually like trying to solve this problem. But then, what you'll see is like it stays just locked down, like because you're not going to be able to push the quality and things like that. Like yeah, there's a lot of work going from a simple demo to something which is actually working in production, call it production grade, right? And secondly, I think we're seeing observability platforms also bringing this in. And here's where I think things get a little bit more interesting because obviously observability has a ton of data. But I guess the biggest constraint we see is that AI is only as good as the data that's below it. And with observability, you kind of have this kind of a catch-22 where it's the pricing model depends on how much data you're sending it. And you're almost disincentivized to send more data. And so I'd say like most observability platforms have a very limited view of what's going on in production because it could be Kubernetes state, it could be code changes, infrastructure configs, all kinds of stuff that you may not be sending to your observability platform. And that's why we think like, it's pretty challenging to address it purely at the observability layer. And lastly, we also look at incident management platforms. And so these products are generally tuned to focus on really high severity incidents. So the goal is that when human attention is so limited, then you need to come up with all kinds of mechanisms to triage and figure out like where should you allocate your most precious resource, which is human attention. And so effective, then you have this classification, right, of SEV 0, SEV 1, SEV 2. And so here it's really the whole design is to figure out like what's an incident and how do we get everybody on it to solve it. Whereas I think that the more interesting challenge or the more interesting solution here is to get agents to work on the really low SEV issues so that you can prevent the next F-Zero, which is a very different way of thinking about it. And I think maybe the more AI native companies are better equipped to handle. Now, if you just think about like from all the three things that I talked about, what's actually missing? I guess the hot take from our end is that the agent is now very quickly becoming the least interesting part of the stack. It's actually getting commoditized very quickly. It's very easy to build your own agent right now. What's actually missing is the memory. And that's what I think is durable. So if you just think about an engineer that's coming into your a company that's just joining, they're probably going to spend some time exploring the environment and building up a mindset or like a mental map of what's going on. Then they'll start working on stuff. You'll give them work to do, and they'll start learning from the work that they're doing. And thirdly, they're probably going to ask your team a bunch of questions and like try to do one-on-ones, things like that. And we think about modeling agent learning around the similar kind of system. So Willem will talk to you a lot more about it, but really just like discover, remember, absorb. That's also like how we're thinking about approaching agent learning. And so once you actually solve this, then I think you get to this sort of almost like a closed loop learning system, right? So today, like what we talked about earlier, you have an agent like Cleric that's actually able to investigate and come up with problems. But then once you actually measure and see how well it did that investigation, and if you can do those investigations really well, it can capture what worked, and then that makes the next investigation better, and so on and so forth, which allows you to really like accelerate the learning that an agent can do. And I think the more interesting aspect of this is that as the agent is learning, it's actually democratizing that knowledge to the whole company, right? So I think about it like if Cleric gets really good at working on the payment service, now the next time the database team is figuring out a problem with the payments database, all the context Cleric's learned from the payment service can actually help the database team figuring out, what's going on with the database. And that's where I think things get really interesting. I'll just hand it off to Willem here to talk to you about exactly how this works.
Thanks, Shahram. Okay, so let me give you a peek behind our architecture, or what we think is a durable architecture in this environment, one that puts memory front and center. So, we like to think about memory in three different layers, and I'll just take them one at a time. The first one is the infrastructure context. So another way to think about this is like, a map of your environment, but it's all the facts that we can extract through a background process. Things like service dependencies and the topology. What are the recent deployments or config changes? And these are not just like your IAC. We're actually accessing real infrastructure. And again, I'm not downloading all the logs and storing it all. It's more about like this index to understand what connects to what and what exists. But also kind of synthesizing that in a way that an agent can use it. This next one we're at is the past investigations or episodic memories. So these are experiences that the agent has had investigating a problem, or a human has contributed. Perhaps these are postmortems that get indexed, but in most cases, these are the agent doing kind of like self-learning as it's doing investigations and improving itself. So it can come in the form of partial facts from an engineer, like engineering corrections or known patterns and baselines by just looking at your metrics, your logs, and kind of like diffing the two and accounting for seasonality as well. Then the final one of the memory system is playbooks or procedural memory. The way we encode these are through skills, but effectively these are kind of like debugging procedures. Often they are grouped according to a service or a team. This differs from company to company. Like in a startup, you might have just like one set of playbooks. And of course, for like an agent, this is encoded differently from a human, where it's like a runbook and it's very brittle. For an agent, it's very amorphous and kind of like distilled and synthesized and kept up to date. But these allow you to like debug through some kind of sequence of actions a specific contextual problem, and kind of triage that, figure out escalation patterns, and maybe even repeated patterns that the agent can identify. So, for example, we're working with a team and they constantly get these OOM kills, and that produces a sawtooth memory, a sawtooth pattern and metrics. And that could be a skill that you develop for the agent and kind of broadly share across your company. So when an alert fires, we basically have an investigative engine that can then kick off. And this investigative engine can then query the memory system, bring in all that knowledge. So it knows what service is associated with that alert, whether it's seen this pattern before, and basically how your team wants it handled. So it can query the live infrastructure, your metrics, your logs, your community state, your recent deploys, all that stuff, and bring everything into memory and then have a very hot start to that investigation. Then after every investigation, the learning system processes those results. So engineers provide corrections in Slack, and so this wasn't the root cause, or this is expected behavior. And you're not going to find that just written down. But when the engineer sees the agent do 80% of the work, they're happy to contribute and teach it almost like a junior engineer. And it adds that into memory as well. So those corrections flow into memory, and in the background, we're also continuously discovering changes in the environment, like new deploys, topology changes, traffic patterns that shift. So the result ultimately is kind of like this closed loop system. So alerts come in on one side, investigations got kind of informed by the memory, engineers review the root causes, provide their feedback, and every cycle makes the system better and better and better. So you're accumulating the 3 layers of memory, and those memories are the bedrock of the investigation engine. Again, the investigative engine is, of course, quite advanced, but it is basically an agentic system that utilizes and gets most of its efficacy from this memory layer. Now, I do want to say that there's like gotchas here. Memories are not trivial to build up and maintain. You need to know what good looks like. So you need a measurement system that can associate like positive outcomes and negative outcomes and attribute those to memories. There's like garbage collection problems. There's people can contribute memories that are contradictory or cold starts. We can chat about that in the Q&A, but suffice it to say that this is the heart of like the product that we've built. So let me just quickly open up a quick demo where I can just walk you through the product. Just see. Okay, so this is our Slack workspace. This is kind of a playground channel. Let me just see if I can trigger an investigation. So I'm just running a script at the back here while that is triggering. Just one sec. Okay, so a typical scenario where teams plug Cleric in is like an alerts channel. So this is, of course, not a real alert, and it's not a real channel, alerts channel, but this is a synthetic example that we have, but there's a real live running cluster behind the scenes. So in this case, an incident is detected, the auth service, and users aren't able to log in. It's not really that interesting what this specific alert is, but Cleric is then able to investigate this. And so it confirms or acknowledges that it's found or seen this alert, and then it conducts its investigation. So this is now happening behind the scenes. I've also got a few ones that I ran earlier, and I'll just click into those. Just open this one up. So as you can see, Cleric is already starting its investigation, and it's running tools, and it's already identified that the pod is in a crash loop back off. And there's a reason it's doing well, because earlier, like if you just go back here, I ran this exact same investigation. And if you click into this investigation, it came up with an answer. And if I open this one up, you'll see a very similar synthesis or answer. The auth service pod is in a crash loop back off. So I'm going to close this older one from 20 minutes ago and go to this one, which is still running. And when this one completes, it's probably going to say something like, okay, I've identified the problem, and it's going to refer back to the previous failure. And the reason I know that's likely to happen is because here it actually accessed past issues. So it's searching as part of this investigation for past issues. So if you get a flurry of alerts, they will all be grouped together and then assessed as one, and not just like started from scratch. And this is a very powerful thing because in large companies, there's a lot of orientation for engineers when they get onto on-call and they have to figure out a problem from scratch. Even if you're senior, it's disorienting and you need to just collect yourself. So this is one form of memory, and this is episodic memory. But I can also quickly just demo what it looks like to speak to Cleric or inform it of something. So here earlier I asked Cleric, can you check the bedrock stats over the last hour and tell me if there are any latency spikes? And in fact, it said, yes, there are some significant latency spikes. By the way, I don't know why there is. I don't know what Amazon is up to, but yeah, a similar pattern was observed in a previous investigation. So, you can say things like, Cleric, always remember that on Bedrock, for our models, we also use, let's say, Sonnet 4.5. So this will be a memory that Cleric will then recognize and store into its memory banks. And this is a form of semantic memory, and you're effectively contributing facts into its memory store. So it'll classify, catalog, and store that memory, and it'll conditionally inject the memory as needed. So in a future situation where I query for what models Cleric is using, okay, save that so I can say Cleric, what models do we run on Bedrock? And it should show us that answer. Okay, let's just see if it's looking up memories. Might be a good one to show. Small loading. Okay, I think while that one loads, I can also show you the third kind of memory, and this one is actually my favorite because as an engineer, I think most organizations have tasks and tasks that kind of workflows that you use to solve them. And so procedures are kind of like a type of workflow, and the form of procedural memory that we think is most useful is a skill. And this is a set of instructions, often natural language, but it can also be code that you can use to conditionally solve certain problems. So as an investigative agent, you might have a procedure to debug, checkout latency. And this is a script that we have, which is a canned one to do that. Um, Earlier, I added this one for identifying service dependencies. It's obviously a critical thing for a team. Like, how do I know what is upstream and downstream from the service? And so we have this like skill bench that you can kind of create skills. So in this case, the skill was generated by Cleric. It actually presented and proposed the skill. And so you'll see a few of them are here where it says, I need your input. And so the agent is coming to you and saying, I need you to fill this in for me, please. And then you can fill that in, but you can also contribute your own. So in this case, let me just see if I can quickly show you what testing a skill looks like. But you can say in this case, let's say for the scenario demo namespace, you should be able to test the skill. So you can iterate on this as an engineer. I mean, you know what your infrastructure looks like, your systems, your processes, and how to debug things. Kind of like the lay of the land. But you want to partner with the agent because you can offload a lot of the work to it. So you edit this text and then refine it by testing the skill and seeing what the outputs are. So let me just run that. It's ready. Okay, so these are some of the Anthropic models. This is the answer to the question I had earlier. And Sonnet 4.5 is there. And also, another thing we do is we give you citations. So we always show our work. In this case, there's a command that you can run to reproduce our findings. And so this is a key part of the verifiability of the product. Let's go to the skill. It's still running. So this will run a full agent in the back, and it will try to validate that this skill is working. And because it's already been saved, I think it should also be able to pick that up. So because we have this skill identifying service dependencies, I imagine you're starting, like an alert comes in and you want to identify the service dependency. Let's create like a contrived situation of that. So what are the upstream dependencies of the checkout service namespace scenario demo? I think something is wrong. Take that one. Okay, I think something went wrong. I'm not sure if this is related to the AWS issues. Okay, normally this will give you a preview of this skill output, and then you can just like green light that and say, okay, that looks good, save it, and then wait for the next alert to come in to verify it. So I think this one should also give you a good example of utilizing that skill. Let me just let this run. For us, I think a key thing is we love the modality shift between Slack and web. It's a critical part of the experience when you're dealing with so much infrastructure as an engineer, even software engineers. There's Datadog, there's Kubernetes, there's runbooks, there's Notion. It's extremely overwhelming. But Slack as the point of call that is the interaction point between the agent and yourself is it just disintermediates all of that. It's almost like working with another human. You can just throw questions at it. So your interaction would be Cleric comes back with an answer like Cleric, what else can you tell me about our AWS infra? And this often is a combination of like education. Like sometimes you forget the code, you forget the infra, and you just want Cleric to like refresh you. And so it becomes this collaboration where you go back and forth with Cleric and getting an answer. And then you iterate towards a resolution with it. So ultimately, what you can also do is you can say, Cleric, okay, that looks like a good solution because it'll present suggestions on what to do to fix it. And then you'd say, ship a PR, and we can create a pull request straight out of Slack. Web, on the other hand, is more useful in the case of like reviewing rich information. So like, answers like the pod status and all these other citations. But it's a more rich experience, and it, of course, takes you out of your flow a little bit, but it's important in critical issues. Okay, so 8 upstream dependencies. And so see, now because of that skill, it knew where to go. It used the kubectl command, and it used these, the object in order to find the envars, in order to find the upstream dependencies. And so it listed all of them here, and it cited this all. And also you can see it also cites past investigations because we also ran this query previously. So that gives you like a high level overview of the surfaces, but these memories effectively are underneath the surface at all points in time and kind of like, drive the product forward. So you're always building more and more memories, and you'll see the tool calls went down to 8 because it's always getting faster and faster because of these additions we make in terms of memory. So that's just the gist. I mean, we can always jump into this in the Q&A more, but that's what I wanted to show you. Let's shift over to the presentation again. Okay. So what's the TLDR like? Where does this actually go eventually? I think it's not that interesting if you do this for one person. It gets more interesting if it's for a team because there's already siloing of information. You often have like the senior, alpha dev or senior principal engineer that knows everything. So you can improve everybody's confidence in production. But where it really gets interesting is if you build this operational memory lake or store, or whatever you call it. Hopefully, even not even just from production, but across different verticals in your company. But Cleric is really focused on the pro environment. And what that eventually allows you to do with Cleric's memory is correlate problems across teams. So if you have like an ML team, they ship a model, maybe there's not a lot of like checks and balances for that team, and latency spikes up, and 3 teams or multiple teams have alerts flaring. What you'd eventually find with a system like this, because it has purview across the prod environment, is that it can connect those dots. Traditionally, this would kind of suck. Like you'd have 3 teams, 3 different Slack channels, hitting their heads against the wall, finger pointing. It's blameless-ish, but often there's one team that caused that. So you really want a system to just get to the answer as quickly as possible. And this is what we see with agents across all industries. Really, it's problem to solution has just become really compressed. So that's what we're so excited about at Cleric, and why we think memory is really the way to go. So TLDR, just to recap everything, AI scaled code, that's good. We love that, but it's hit a wall in production. The current tools we have are kind of slapping on AI features, but it's not closing the loop. They're very open loop systems. You need the investigate, measure, learn loop in order to accumulate that memory and improve over time. And we think that memory is really the key component to building a system that works and crosses that kind of like 50, 60% demoware barrier. And finally, the corrections from engineers improve the product, and the memory ultimately becomes a thing that connects all of your teams, and it just allows them to understand prod. So let me just stop there. We've said a lot. I'd love to open it up for questions and for Q&A. I like the question around context can be very large. Are you using, okay, I'll repeat the question. I think that the context can be extremely large for complex systems. How is that handled, stored? Are you using graph databases or other more concrete systems to answer questions agents may have? I'm concerned that agents will hallucinate facts that could drive the investigation in the wrong direction. Maybe I'll answer the first part and you can answer the hallucination part, Charm. I think it's a bad idea to kind of store all the information again. Um, the data richness is a problem that humans have. Like that's a problem that AI is becoming increasingly good at solving. Like we can find needles in haystacks of logs very quickly. We can parse object from Kubernetes and instantly point to the colon that is out of place, the white space that's out of place. So if anything, I think that's more a challenge for humans than it is for large language models. But from an indexing perspective, we basically create enough breadcrumbs for the agent to be able to pull strings and query live systems. That's why agents are so much more effective than RAG, because in RAG you're basically storing embeddings and querying large documents, and that would be very dangerous. You'd fall over. But for agents, they can be very judicious about the information they retrieve. Uh, Sharm, do you want to take the next one?
Yeah, I mean on the hallucination of facts, like of course, like what we're storing in this sort of context layer, like what we're learning, we attach confidence to those. So, for instance, if the user gives us a memory that says like the auth service is definitely in the payments namespace, or we have background extraction where we know something is true because we verified it. That's a very different thing from, say, for instance, a past investigation where we probably, you attach less confidence to it. But I think just in terms of like the hallucination, I'd say it's less of a risk here because the whole point of like the way we defined or designed the investigation flow is to go corroborate a hypothesis with as much evidence as you can find, right? And so if we don't find enough evidence to like justify a hypothesis, then we'll just say so. So really, to us, the problem is more of how do you make sure you don't waste your time, which I think is what you were implying with that question. Like, if we hallucinated facts, could we just go off on a wild goose chase? But part of that, it could even happen even without any of this memory, right? Like, you could find a red herring and really spend a lot of time there. So a lot of the focus we put in is to just try to detect that we're in this loop and try to stop. And sometimes, like in the worst case, the agent will just stop and ask a question like, "Hey, I'm not sure how to proceed. These are three like threads that I could follow. Which one do you think I should go on?"
Yeah, I want to double check that last point. This class, this generation of models, along with the right, product layers on top of that, it's become good at pushing back and saying, I need to stop here, versus prior generations that would just go on and on and on. In that generation, you'd maybe throw more tokens and more processing at the problem, but nowadays we can stop very effectively. Another question in the Q&A is how long does it take for Cleric to build useful memory on a new environment? So I can take that one. When you drop Cleric into an environment, the background discovery starts immediately, so we're constantly running that. There's of course like an initial mapping and scanning, and then we're like slow polling and continuing to update that map. That is informed heavily by the changes that you ship. So if you're constantly changing one service, we're going to keep updating that and making sure that we have a good sense of that. Or if alerts are firing for one service, it's kind of a recency bias that we have that just makes it more effective. Of course, past investigations accumulate with each alert. So every time there's an investigation, the episodic memories will improve. Skills take a bit longer because they require repeated patterns to be identified. So with skills, you may need to run perhaps a week or two, but it really depends on your team and like how quickly they are able to interact with the product.
Well, that's the question.
Sure.
I'll read it out. As an extension of Fred's question, are you separating the roles each agent is taking in an investigation flow, such as Confluence agent or Infra agent? We do. So it just depends on like the context. So for the investigation agent, of course, we use a concept of sub agents, and they have different roles, right? So like we'll have a log sub agent, GCP agent, Datadog, things like that. And it's mostly helpful just to conserve context. So if you can, abstract the problem or divide it in a way that you don't, like, the main agent just needs to know what are the most interesting logs, for example, in Datadog for a certain problem, then the Datadog subagent can go and find it and come back to the main agent and report back. And then the main agent can use that to, adjust its plan and keep proceeding. It doesn't need to know all the intricacies of what's happening on the Datadog side or Confluent side. Hopefully that answers your question. Got another one from Fred. How well does this work in practice? What are the challenges you're seeing? I can take that.
Sure.
Uh, Last year, I'd say it used to suck. It was like, I think with like in the SRE use case, you can't be right 5 out of 10 times or 50% of the time. It's not very helpful. Um, but frankly, now we're at the point where it's gotten good enough that we're just sort of trying to we've shifted our efforts almost entirely on helping people use the agent. So I think it's more like you're kind of constrained by your creativity. There is one side of it though that I think we're still at the point where these products work best with more senior engineers. Um, and the reason for that is when Cleric goes and jumps on a problem and starts investigating it, as an engineer, I can't really explain how it happens, but you have a spidey sense whether the agent is going to get to the right answer or not, because you've just seen so many of it. So when you get a response back from the agent, your spidey sense will tell you that you should follow up more or you should just accept it. And we're trying to make that more accessible to more people, but that has a massive effect on your perception of like how well the agent is doing. Because when you see something like a 70% answer and you know it's 70%, then it changes your impression of it because now you just need one more follow up and you get to 100% and you're happy because it saved you time. But where it goes wrong is you see a 70% answer and you assume it's 100% and you just act completely based on that. And then, maybe the problem crops up in a different way next week, and then you feel like, wait, I didn't actually solve it. So it's still, I think, quite dependent on sort of your level of experience. And obviously, like that's an area that we're focusing a lot. But I said that would be like almost like the biggest challenge that you're seeing, which is sort of we see agents as a skill now, and like the more you use them, the more you build these intuitions. And we're trying to figure out, like through workshops and things like that, how do we actually help engineers like build those intuitions very quickly so they can be more
Yeah.
effective users.
We actually had a workshop this morning where somebody brought this up, and it was very clear that we work with teams where there are folks that are less confident in production. Sometimes it's even non-technical folks using the product, and there are sometimes very senior SREs or senior staff level engineers. Those engineers will say things like, "Don't tell me it looks good. Tell me exactly what you found and what you did." And there's a specific way that they want to be spoken to and the information communicated to them. In the workshop this morning, the non-technical person was asking for a confidence score from Cleric. So he wanted Cleric to provide more information to him so that he knew how sure Cleric was before he would accept that information. And so the UX challenges are now becoming more front and center as we work with teams with different levels of experience.
We did one. We shipped something. I think was it last week, Willem, or 2 weeks ago, where we actually started adding dynamic follow-up buttons,
Yeah.
because that was another thing which we felt we could make it easier. So if you know that it's 70% and you're good at framing the next follow-up question, then you're going to get more value out of it. Whereas like we have actually started getting Cleric to generate like what potential follow-ups could be, and that's been really helpful.
Yeah, I might be able to just quickly share that. Can you see my screen?
Yep.
Hopefully it's big enough. Yeah, so it generates these like little uh, buttons for every investigation. So the failure here was, it's a crashing, and it does basically next best action prediction. Like, what is the thing that it thinks that the engineer would next want to do? But this is an incredibly important source of information for us because depending on what you click, it'll inform our memory system. So this is a follow up from me to say check the Argo CD sync status because perhaps in the past we saw that was the problem. So this creates a delicate balance because in theory you could go all the way and try and guess like the answer or like, but there's often like this horizon of confidence where we will stop and then present options to the engineer. So it really becomes a collaboration. Another question in the Q&A stream is if we have hundreds of microservices, how would this scale? So I can talk about it from like, I think the more interesting point is like, where do things fall apart? Often the challenge is there's kind of, sorry, I do want to just show you this one thing, but I'll keep this on screen. The challenge is often with large scale infrastructure. So I just came back with the answer. Um, how do you localize the problem very quickly? And again, this comes back to memory. Do you have a topology of the infrastructure? So a large part of what we do is categorize and classify and organize information. So if you give us a fact, we will ask, okay, who presented this information? What team are they on? What services do they own? What are past incidents that they've had? So we will bucket one piece of information across multiple kind of collections of facts, sorry, of stores of that for that fact, and then we'll inject that later. So that storage and injection and garbage collection is really what allows us to quickly jump on a specific alert and be accurate. Otherwise, this falls apart at scale where you're just flooding the edge with a bunch of noise. And so that's the only thing that we need to do to keep up the scale, because we're not serving like very high load. We're not storing logs. There's nothing like intense from like a data or a streaming or compute perspective. Okay. Maybe you can take this one, Shahram. What's the difference between this and just writing better runbooks?
Oh. Well, you should write better runbooks because it'll make you better at looking at your system. Um, but I mean, the whole point with runbooks, I'd say two things. One is runbooks very quickly get out of date. I think we all do our best to try to keep them up to date, but it's hard. And secondly, you can never write enough runbooks to cover the breadth of potential problems that you may have, right? And so I think I like to think about like an SRE agent as almost like dynamically generating a runbook for every single unique issue that you get. And ideally, like we're building better and better runbooks for that one investigation. Um, but that said, I think the sort of the hidden value of runbooks, which I think, as an industry we need to figure out, is that when you are writing runbooks, you are forcing yourself to persist learning. And so you did a thing, you built the run book, and you share it with your colleagues. So sort of it's a really good way of storing things in memory. And I think just like with using agents, I don't think the answer is, oh, the agent's going to do everything, and then we're just going to let it and watch it solve everything. So I do think that that sort of facet of run book should be brought over to this new world where you can still maintain that learning and sort of work in progress on what that looks like, but it's something we think about a lot.
How are we doing on time? Is there time for one more?
Yeah, to do one more. I think we're at time, but let's squeeze in one more.
This is actually an interesting one. It doesn't sound interesting, but it's actually very important. How many integrations does Cleric need before it's useful?
42.
That's what I thought as well. But we've actually run into this a few times. A part of the challenge is we work with teams where they want to do a pilot and they're like, let's connect Cleric to as few systems as possible and see what it can do. It often doesn't do well if you don't give it prod access. I think where we can sneak by is if we only have like a Datadog and maybe code, so that we can at least know if a system is down. But most of the time, we need to get access to Kubernetes, your code, and at least logs to be able to do damage in a good way. But then if you add a
I think
few more
that,
systems, go for it.
no, no, finish. I'll close up.
Yeah, I think then if you add traces, metrics, you add like your knowledge base, then suddenly we do significantly better.
One of the things I like to think about with agents is that if the human engineers are struggling with whatever data source that you provided it, the agent will struggle probably even worse. And so the best favor you can do for you and the team is to actually make it easier for your fellow engineers, right? Like if your logs are a mess, if your metrics are a mess, or you're just dumping all kinds of crap in there, which like nobody's actually looking at, then I mean, giving the agent lots and lots of integrations is really not going to help either. So like I guess like the mantra which we've been following is like what's good for engineers is good for agents. So, treat your engineers well, and the agents will also thank you.
All right, I think that is the session for today. We will also share a recording of this webinar with everybody that's joined. Thank you.
Wonderful. Thank you.